Okay, we're talking about lesson 10.9 here in geometry. So this lesson is about arc length. Now, yes, this lesson is from chapter 10, even though we're moving on to chapter 11 now. But we talked about it briefly back in chapter 10 that every time we were talking about an arc in chapter 10, we were talking about arc measure. That was in degrees. Arc length is how long is that arc in centimeters, inches, or things like that. And if we put them both into the same chapter, it gets very confusing about which one we want and when. So that's why we just keep them separate, and 10.9 we just squeeze in with chapter 11. Chapter 11 is about area, and this idea of how long this part of a circle is actually ties in pretty well. So that's why this is in chapter 11 and not in chapter 10, like it seems like it should be. So here's the first problem. It says, okay, we're going to find an arc length here. So if you notice, I've got my central angle marked in this circle here. So central angle C. Notice that it's marked as 40 degrees there in that circle. And let's say that I tell you the radius of this circle is 8 centimeters. And I know that the measure of this angle is 40 degrees. So what we want to find now is the length of arc AB. Not the measure anymore, but the actual length. So when we're talking about arc length, we can kind of picture like here's a guy standing at A, and he needs to walk all the way to B. And how far would it have to be that for him to walk? That's what we mean. How long is that curved portion of that circle from A to B? Now we hopefully will know arc measure pretty well, right? That was from chapter 10. So if this is a central angle, and I know that the central angle measure is 40 degrees, then the arc measure is the same as the central angle measure. So the arc measure is also 40 degrees. But now I want to figure out arc length. So if I really think about it, can I figure out how long it would be to go all the way around the circle? Well, the distance all the way around the circle, that's called the circumference, right? So the circumference of this circle would be 2 pi r, or 2 times 8 times pi, right? So in this case, it would be 16 pi. That's how long it would be to go around the entire circle. But he doesn't have to walk the whole circle. He's only walking this portion of the circle. Well, how much of the circle is it that he's walking? Well, it's just this arc measure out of the whole 360 degrees, right? So this would be the arc measure out of 360 degrees. So in this case, it would be 40 out of 360, or I guess we could say that this would be 1/9. So the arc measure out of 360 degrees, that's the fraction of the circle that I have to walk, not the whole thing. So I want to have that fraction of the circumference, or that 40 out of 360 times the 2 times 8 pi, or 1/9 of 16 pi. So when I do 1/9 times 16 pi, I would get 16 pi over 9. Or you could think of it as 16/9 pi. Either way though, we do need to label our answers. Pi is not a label. Pi is a number. So don't forget, when you have pi in your answer, that's not the label, that's part of the number. So either way you want to say it here, 16 pi over 9, or 16/9 pi centimeters is how long it would take him to walk. So if I look at that, this part right here, that's the big idea for today. That's how we find arc length, is you take the arc measure over 360 times the circumference. In fact, I have a place for us to write it down one more time right here. So it is arc measure, that's in degrees, out of 360 times the circumference. And That's the only formula from today. You're going to see in your practice problems and your homework how you can use that, but really that's the big idea.